Hello viewers, now I am going to explain about this effective stress. So before going to in detail about this effective stress, we should know first what is meant by total stress, next pore water pressure, and third one is effective stress. We simultaneously learn these three concepts. So this total stress always we indicate with sigma, and this pore water pressure we indicate with small u, and this effective stress we indicate with sigma bar or sigma dash. And let me define what is meant by this total stress. This total stress is nothing but it is the stress due to weight of soil, or we can define it as it is the sum of effective stress and pore water pressure. Okay, so according to this definition, this total stress is given as sigma equal to sigma bar plus u. This mathematically, this total stress we write total stress equal to effective stress plus pore water pressure. So let me define what is meant by actually pore water pressure. It is the pressure exerted by water which is present in the pores of the soil mass. So what is meant by this pore water pressure? It is the pressure exerted by the water which is present in the pores of the soil mass. For example, this is one of the soil sample we are having, and so some of the voids are filled with water, and for a partially saturated soil, if some of the voids are filled with water and some of the voids are filled with air, and for the saturated soil, all these voids which are existing in this soil are filled with water. So there will be some pressure between this water and this soil particles like this, isn't it? The pressure exerted by the water which is present in the pores of the soil mass, we call it as a pore water pressure. Okay, so the determination of this pore water pressure we discuss later. Let me define what is meant by this effective stress. Next one is effective stress. It is the intergranular pressure. So what it is? It is the intergranular pressure. Effective stress is nothing but it is the intergranular pressure. For example, these are the soil particles. So in a soil sample, some of the soil sample, the pressure between particle to particle exists, right? Isn't it? The pressure between these intergranular particles we call it as a effective stress, and this is what it is, the intergranular pressure we call it as a effective stress, and the pressure exerted by the water which is present in the pores of the soil mass we call it as a pore water pressure. And total stress is nothing but what? It is the summation of this effective stress and pore water pressure. So mathematically, this effective stress equal to total stress minus pore water pressure we write. Okay, and this pore water pressure is equal to gamma W into H. Okay, so where here H suffix P and this H suffix P equal to piezometric head. With the help of piezometer we determine actually this piezometric head, and gamma W is the unit weight of water. Okay, so from these we can determine this effective stress by knowing this pore water pressure, and by knowing this total stress we can determine this effective stress. The determination of effective stress is very important, and soil properties nothing but shear strength and compressibility characteristics depends on this effective stress. It is very important concept. Okay, so next we will discuss about the determination of this total stress and pore water pressure. Okay, first one is total stress sigma, and this sigma is determined, this total stress is nothing but what? It is the stress due to weight of the soil mass. For example, this is the ground surface, and I want to determine the stress at a depth of Z from the ground surface. Okay, so here I am taking one of the rectangular prism like this at a depth of Z from the ground surface. Let A equal to area of cross section of prism, and next Z equal to depth or height of prism, height of rectangular prism. So this actually this what we call this total stress equal to weight divided by area of cross section. Here the stress due to weight of this rectangular prism, the pressure the stress induced at this at a depth Z, right, that we call it as a total stress. So this total weight of this prism divided by this area of cross section, isn't it? The area of this cross section will give the total stress. This actually we know that let gamma sat is the saturated unit weight. Why? Because okay, so assume it as a gamma sat. Okay, ground water table is up to ground surface, and this is saturated. Let gamma sat is the saturated unit weight. Now this saturated unit weight will be equal to weight divided by volume. So from this expression we can write this weight of saturated soil, right, isn't it? Okay, so saturated weight of soil we can write equal to gamma sat into volume. So this gamma sat into volume we can write area into Z, right? Okay, so here Z is the depth or height of this rectangular prism, and A is the area of cross section. This volume we can write area into Z, right? Okay, so by substituting this saturated weight of soil in this expression, what we got this total stress, it will be equal to gamma sat into A into gamma sat into A into Z divided by A. This area will get cancelled, and you will get gamma sat into Z. This is the total stress at a depth Z from the ground surface. So if you want to determine the pore water pressure, for this case the pore water pressure at a depth Z from the ground surface we can determine by using piezometers. Okay, for example, if you keep one of the piezometer here, then what will be the height of water in this piezometer? Okay, so up to this ground surface Z, right? And this pore water pressure U, we can write it is equal to gamma W into Z. Okay, so this gamma W into Z will give the pore water pressure. So now total stress equal to effective stress plus this pore water pressure U, isn't it? And from this expression we can determine sigma dash or sigma bar equal to total stress minus pore water pressure. What is meant by total stress here? What we have determined, that is gamma sat into Z, isn't it? Okay, so here gamma sat into Z minus gamma W into Z. So from here I can take Z as a common, gamma sat minus gamma W. So from this Z into gamma dash, where this gamma dash equal to submerged unit weight, we call submerged unit weight. Okay, so from this one we can determine this effective stress. So after determining this total stress and after determining this pore water pressure, we can determine this effective stress. And this effective stress, so the shear strength of the soil, shear strength, that is of a soil, depends on effective stress of soil. So and the decrease in volume also depends on effective stress. Okay, so this shear strength parameters and this decrease in volume of the soil depends on this effective stress. For example, if the effective stress is more, then shear strength will be more. If effective stress is less, then shear strength will be less. If effective stress is more, then volume change, decrease in volume will be, change in volume will be less. And if effective stress is less, then change in volume will be more. Okay, so this is the very important concept. So if the effective stress is more, means what? The particle to particle contact is more. So that is the reason if we apply some amount of force, then volume change will be very less, isn't it? Okay, so that is the reason this effective stress is very important. This shear strength and this change in volume is these are very important parameters. Okay, so this depends on this effective stress. Okay, so this is about the determination of effective stress and total stress and pore water pressure. Okay, thank you. In the next class we will discuss remaining concept.